Hi, I'm Ivan Minčík. I'm from Slovakia. I came to tell you something about Nix technology and ecosystem and how to use it for your geospatial project. It's a huge topic. I have 100 slides. I need to be really quick. I'm a long-term Linux user, geospatial software user. I started contributing to Nix in 2021, and this year I started Nix packages or Nix geospatial team. Yeah, and if you want to know more about Nix, I have a specially customized badge. This is how you can recognize me. This is a Nix logo. Just come to me. There will be probably no time for questions. Yeah, so what's the problem it's not the problem, but this is the current state of geospatial software. We have multi-level dependencies in our software stack. We have core libraries which don't depend on anything geospatial usually, which is like Project Geos, and then we have another level of core libraries which depend on those libraries, and then we have Python libraries which depend on what's below on those core libraries, and then we have another level of Python libraries which depend on those Python libraries, and they depend on this, and then on top of that we have databases which depend on anything below, and we have web applications, we have desktop applications, we have AI applications, and they depend on whole stack, and we totally depend on those core libraries to provide us access to formats, to transformations, to some processing pipelines, and we are extremely happy if new format is added to GDAL or some bug is fixed. But the lower the change happens, the bigger is the impact on anything which is on top of those libraries. So many times there's a bug fixed and we want to apply this straight away to whole our stack. But there are situations when even if it's a bug and we have a bug fix, it's going to break our processing pipeline, because our processing pipeline works that way, and the fix is going to break. So we don't want to apply it immediately. And sometimes we can't even work with the latest version because it doesn't work for our use case, and usually we have heaps of projects. We don't have one project, and all those projects have different requirements and different life cycle and different age. So this is how many dependencies are coming to play to Python Fiona library. This is the core C library, and this is all of those dependencies you need to successfully run Fiona. Basically, it's really a lot. So how we install our software? Sometimes we compile it from source code. Sometimes we get it from Linux distro repos. We get it from PPAs, ours, Flatpak, snap images, container images, and anything else. So it's a huge mix of software, and different kinds of software come from different vendors and different sources. So this is typical example. You have Ubuntu Linux, you install GDAL, Geos, Pros, core libraries from Ubuntu GIS. Then for some kind of data processing, you install Fiona to your Python virtual env. By the way, Fiona comes with GDAL. Again, it's optional, but this is the default. You can turn it off, but it comes with GDAL bundled in the wheel. For data processing, we install QGIS using Flatpak, and then we have some web service installed to our Alpine container. So typical problems which we usually have, because everything comes from different vendors, we have totally inconsistent libraries. We can have 5 different GDALs easily on our computer, one from Flatpak, one from PyPy, and so on. We are going to have problems to replicate it on different platforms. Ubuntu GIS doesn't usually work with Arch Linux, doesn't work with Mac OS. We might have huge problems to reproduce it in after 5 years from now. And like the biggest problem is how to support like really dozens of projects of different age and with different requirements, different software versions, different customizations. So Nix really can solve that. This is one of the main purpose why it was designed to really like correctly run software on our computer. So what is Nix? There are like many components of basic Nix ecosystem. I'm going to talk about the main ones. So the main one of the first thing is Nix as a package manager, the first component. It is really not using these words for no purpose. It is really the most unique and advanced package manager. It is cross-platform, which means it runs on any Linux distribution. It runs on Mac, it can run on Windows WSL2, and the outputs of Nix are bit-to-bit reproducible. This is reproducibility is a big topic, more on that later. So it can run multiple versions of software without dependency conflict. This is not very common thing. Nix doesn't conflict with other package managers or software on your whole system, so you can run your Ubuntu and app and you can still run Nix easily. And it has very strong cross-compilation capabilities. It can build container images, it can build data processing pipelines, it can build operating system, it can build whatever basically you want. So this is the example of single application installation, like traditionally looking way how to install software. So Nix profile install GDAL from somewhere. So this will install GDAL for the user executing the command. You can have multiple profiles, multiple users with different things, but this is not the best way how to do it. It's just like an example. You can create some temporary on-demand environments using a different command called Nix shell. This will install GDAL as well. You can play with that, do your work. If you do exit, you don't have GDAL anymore. You can run software from any arbitrary internet repository using another command, Nix run. There's a GitHub repo, my GitHub repo, and it's running QGIS long-term release just with option to print the version. You see before I was not able to access, after I was not able to access QGIS. So it's just like example of just running software without anything else. This is the example using old command line interface, how to run on current Ubuntu version, how to run GDAL 1.7, no problem to do it. So to describe, to write, build instructions, and everything at Nix, we are using Nix language. It is pure, lazy, evaluative, functional language. This means something. I'm not going to dig into it too much. We use it to write build instructions, which means packages, modules, functions, and you can think about it as a JSON with functions. It is really like a good mental model for starting. This is the example of basic build instructions for geo. So we have a function which takes a few arguments like the name, version. Then we have another function which downloads the source code from internet. It has exact hash of the content of the source code, and then we have key dependency CMake, and Nix will automatically build GDAL from this instruction. It's not going to be like the best possible build configuration under the sun, but this is the basic example of it. So another core component of Nix ecosystem is Nix packages. Nix packages is really the largest and most up-to-date collection of packages on the planet. We build packages for Linux and Mac OS on different platforms. Nix packages contains free and non-free software. A lot of non-free software which is not built, but you can use Nix install this non-free software just to be compliant with licenses. It already contains heaps of geospatial software. We have 12,000 GitHub stars, 10,000 forks. Usually we have like 5,000 open PRs. Like in 1 month, we can merge 5,000 of them, open like 1,000 more easily. So this is the graph showing amount of packages and their state of like their freshness. So this is amount of packages, this is freshness of those packages. So here are Linux distributions, Debian and Ubuntu and everything else. Here is Nix. So Nix has that more amount of packages, which is only comparable to Arch Linux. I think it's even more currently, but like Arch, this is not official Arch repository, this is Arch user repository, which contains like everything. And our packages are more up to date, even comparing to Arch user repository. So number of contributors is really growing each year. As you can see, we have now like around 1,000 contributors. The problems are always present. Currently, we can't build QGIS on Mac because there is like not enough Mac knowledge, I guess. So another component is Nix operating system, another very unique operating system. It is declaratively configured, which means like you say what you want, not how to get there. I want PostgreSQL, and it will give you PostgreSQL. It is configured using a module system. Software comes from Nix packages, 2 releases per year, and dozens of another very unique features. This is an example of configuring Nix OS. So like here you can see I said I want service OpenSSH running on this port. I want PostgreSQL. I want these 2 databases to be present. I want them to be backed up. So service PostgreSQL backup. And I want to back up these databases. And I want to XFCE desktop available on my computer. This is enough to get full operating system running database and desktop. So Nix community provides another heaps of other software tools for Nix. So what are the others saying about Nix? So I picked up a famous example from Michel Hashimoto, who is really like not some random person from internet. He's really very smart IT person, author of Vagrant Packer Console, Terraform, Vault, Nomad, and heaps of other things. He's saying that the Nix learning curve is like a sheer cliff, hardest learning curve of probably in tech I ever learned. And this is from a person who knows really everything. So it's a quote from 2021. In 2022, he's saying is that he is still using Nix, and the problem with Nix is how quickly you lose touch with reality of others in terms of managing dependency versions. So he forgot that there are some dependency hells in another world. So very positive quote. And in 2023, he said, "I still stand by." Nix is the #1 most positively impactful technology I've learned in recent years. So this is like really bold statement. So a little bit of history. This is the guy who started whole thing in 2026, writing his famous PhD thesis, Elko Dolstra. Then there was another guy doing a master thesis, which kicked off Nix OS operating system. In 2008, got a module system powering Nix OS. In 2015, there was the first NixCon. Elko is still like very active in the Nix community. I met him one month ago at the meetup. So this is the first sentence of his master thesis. This thesis is about getting computer programs from one machine to another and having them still work when they get there. So it's still valid point. Basic examples, I'm really going to simplify that. The biggest topic is reproducibility, which means the same inputs ends as exactly same outputs, bit to bit or back to back. To achieve that, everything is built in like very strongly isolated environment from host internet and with heaps of configurations, which guarantees that it always ends up exactly like that. Whatever Nix builds, it ends up in Nix store, which is special directory Nix / store, and ends up in a subdirectory which is called storepad, which is named using unique cryptographic hash based on inputs of what you are building. Same inputs always end up in same hash and vice versa. So this is the example of Nix store directory. I built GDAL, I built another GDAL, built QGIS. So if you see, this is the same version of, the structure is hash, package name, and version. This is the structure for packages. We can build different other things, but this is example for packages. So we see we have the same version of GDAL multiple times, which means that I build the GDAL probably with different page or different build configuration here, and I can run them. This is the content of the directory, familiar directory structure of GDAL, nothing extremely special there. And the key concept is that the software can't just run, like the package just can't run by itself. It always needs to run with all dependencies, including basic C library, and all those dependencies must be exactly those which that package is intended to use with exact hash which belongs to that package. And there's another, So this is the example. If you want to run GDAL, it needs all this software down to glibc exactly with those hashes which guarantees the exact build. And if one package needs equally same dependencies as another package, they are nicely reused between those packages. This is the very big advantage over Flatpak, for example. So you share what you want, what you can. Because it's reproducible, if I build software on my machine, it doesn't need to be built anymore. It is stored in cache. We have a local cache on our machine. We have official Nix packages cache. We can have another third party or by us built cache services, and we can forever use once built package or any kind of output. So why reproducibility is important? We can have exactly bit-to-bit same environments for dev, test, UAT, CI, production environments. We run and build, we can run the same software build once. We need to run a test suite only once if it's running against reproducible software. So for example, for science, it is even more visible. You can share your environments with your experiments for others to reproduce that. There's a famous article about reproducibility crisis in Nature magazine 2016, which is saying, really 5 minutes, which is saying that 70% of researchers have tried and failed to reproduce another scientist's experiments, and even more have failed to reproduce another So how to install? There are two installers of Nix currently. Both are good, and some of them enable some features, some of them not by default. There's an installation. So how to use Nix for geospatial environment? So this is a typical project setup and requirements. I want to pick up my machine, initialize Git repo, and get project dependencies and start basically working. I don't want to bloat my system and break other projects. And over the time, I want to update my dependencies with configuration, roll back my changes, customize with packages, with patches, and yeah, I want to skip some other slides. So how to use? Sorry. Okay. So what is GeoNix as a point of this presentation? It's my proof of concept project, which is building per project development environments for geospatial projects. It provides the latest geospatial packages like Ubuntu GIS, but for all Linux distributions and Mac and Windows. WSL. It provides isolated project environments like Python virtual env, but for all software. It provides some functions for running geospatial services like PostgreSQL and others. It can build container images. So how to start GeoNix project? There's a command GeoNix CLI in it, and it will give you two files. One of them is a configuration file where you configure your project in a form that you create some kind of shell environment. So here I'm creating two shell environments, one for packages, one for services. Default is for packages, PostgreSQL is for services. There are different functions which allow me to do so. So how to launch those environments. So everything I need to do in my root directory of my project is to say Nix develop and name of the environment. So if I do Nix develop default, I have all packages coming from default environment. So I specified GDAL there, so I have a GDAL. If I do Nix develop PostgreSQL, I have a nicely running PostgreSQL running under my user in my project directory. If I want to add more stuff to my shell environment, I just add them to extra packages parameter of the function. There are other parameters or arguments of the function as well. So this is extended. I added few packages and calls a message to my environment. If I want to develop Python, there's another function, make Python dev shell, which turns my environment to Python environment. I can specify version, I can specify my dependencies. For example, Fiona, I can have some non-Python packages there. So if I re-enter my shell environment and say Nix develop default, I have a Python prepared environment. So I can, for example, try Fiona. If it works, it works. I can even use Poetry to install additional dependencies. So I installed Flask from PyPy, and it works nicely with what comes from Nix. I can extend PostgreSQL by just like saying I want PostgreSQL 12 and PG routing to be present. I can add more of another environment, for example, some client environment, which allows me to easily to connect to my PostgreSQL. And I just made one more mock web environment, just running Python server. I checked if I haven't done any mistake in my configuration. These are environments which I created. They are immediately available for Darwin, which is Mac, and for Linux. Thank you. And you see I'm running PostgreSQL. I can connect to database. This is my web service. If I don't want to run all those services by hand. I can use process compose, where I just list all my services in one file. And if I run process compose, I have a nice UI which starts all services, gives me logs, like Docker compose, for example. There's even a way how to, this is another killer features, how to patch packages. For example, in this example, I try to create a patch which is just like overwriting the version of GDAL to something else. I just use that patch in my project configuration like this, and I just re-entered my development environment, and Nix evaluated my change and rebuilt everything which was needed. So it's not me knowing what needs to be rebuilt, but Nix exactly knows what to rebuild, and I just re-entered my shell environment and everything was done. So you see here, all software is now using that custom GDAL version, revision 99. It's QGIS, it's Fiona, it's PostGIS doing that. There's a way how to log packages to certain version, how to update them, how to roll back to previous version. You can do you can compare different commits using different dependencies and find if they break something, and you access, so there are other similar tools like GeoNix. There's a DevEnt, which is done by really like Nix gurus and veterans, and it has another heaps of features how to enable 50 most famous programming languages using module system similar to Nix OS. You can start services by just like saying, I want to have PostgreSQL, I want to have some kind of containers. There are other tools as well, DevBox, it has this kind of configuration. All of them are using Nix. So like last three sentences, my conclusion really like after a couple of years using Nix is that containers were really the best development environment until I discovered Nix. And Ansible was really the best configuration management until I discovered Nix OS declarative module system configuration. Yeah, so if you are interested, just come to me, and thank you very much.